In this class, I am going to discuss with you nth root of a complex number. See, nth root of a complex number. Let us take z be the complex number. See, let us assume that z is equal to x plus iy is a complex number whose nth root we are going to find. You know how to express this complex number into the polar form, or you can call it as modulus amplitude form. How do we express? You know that. See, take this organ plane and this may be located in any one of the quadrant. So here I am assuming this complex number over here, and if you connect this point from origin, so this terminating ray makes an angle theta, drop perpendicular from this point to x-axis. See, let it be P and this is A. Now you know the distance from here to here, let it be R. Now the R value is root x square plus y square. And here, from here to here it is x, from here to here it is y. Now define cos theta. Adjacent by hypotenuse, x by r. Now x equal to r cos theta. The same manner define sin theta. You get y by r. Now y equal to r sin theta. You know all this. So theta is called argument or amplitude of this complex number. So if you want to write theta, you will get tan inverse of mod y by x. You know this. This will come by dividing this by this. Now write this x and y value over here so that you will get z is equal to r cos theta plus r sin theta. See, if you write this x value, y value here, then your complex number will become, what do you get? Nth root of, in place of this, write this value x plus iy. Here x value r cos theta, y value r sin theta. Take r common. So inside you will get cos theta plus I sin theta. Now here this can be written as r cos theta plus I sin theta whole power 1 by n. You know students, here theta is argument of this complex number, so which belongs to close interval of minus pi 2 to pi, which means that you know, you start from here. If you measure an angle in the clockwise direction, you have to represent with minus. From here to here, how much angle rotated by us? Minus pi. From here to here, anti-clockwise pi. So minus pi to pi means from here to here. You get theta belongs to minus close interval of minus pi 2 to pi. Okay, so you can also call it as principal argument of this complex number. Now see students, apply the De Morgan theorem for this. If you apply De Morgan theorem for this, here bracket you have to put, here also one more bracket. Apply the De Morgan theorem for this. On applying De Morgan theorem for this, now it is going to be, see here, it is looking like A, this is B. AB whole power m can be written as A power m into cos theta plus I sin theta whole power 1 by n. Now r power 1 by n, now it is written as, okay, apply the De Moivre theorem for this. If you apply the De Moivre theorem for this 1 by n will come in the place of theta, theta by n, theta by n. You know that. But here I would like to write, see, first I want to write this 1 by n at the coefficient of theta, so that it will become cos of theta by n plus I sin theta by n. So in the short manner, it can be expressed as cis of theta by n, where theta belongs to closed interval of minus pi to 2 to pi. But if you want to write general solutions, so what you people have to add here? 2k pi in the place of theta. Theta is the principal value which belongs to this interval. Suppose if you want general solution, what you have to do? So in the place of theta, what you have to write? R power 1 by n cis of add 2k pi plus theta by n, where k belongs to 0, 1, 2 and so on till n minus 1. This is very important. Here why I am adding 2k pi? So this is a standard form of complete angle. So in the one rotation, you get one solution in this. If you keep on moving many times, you will get many more values for this. So why I have added here 2k pi? To find the general solutions. Here condition for k. So here 0, 1, 2 and so on n minus 1. Remember this. Okay, this many roots we get for this complex number. Okay, what it is? Nth root of a complex number. How to find nth root of a real number, you know, like cube root of 125. Simply you say it as 5. Like fourth root of 256. So 4 is the answer. You did this kind of problems. So in the school education. But here we came to the complex numbers. Why our mathematicians have been introduced with the complex numbers, you know. Actually to do all the mathematics problems by real numbers is not possible. So that real number set they extended as complex numbers. So this is a way to find nth root of a complex number. Nth root of a complex number is equal to how much? R power 1 by n cis. So what is meant by cis? Actually it has to be written cos of 2k pi plus theta by n plus I sin 2k pi plus theta by n. Okay students, in the short manner I have kept as cis of 2k pi plus theta by n, where k runs from 0, 1, 2 and so on n minus 1. Nth root of a complex number will get n roots. So if you count all of them, you will get n roots. If you keep k equal to 0, you get one root. If you keep k equal to 1 here, you get one more root. Till you have to substitute n minus 1. N you will get from here. Okay students, for example, I am giving you one question. See, find the fourth root of root 3 plus 1. Find the fourth root of root 3 plus 1. Now how do you answer to this question? Tell me. So, see, the first step, what you would have to write? Root 3 plus 1 whole power 1 by 4. Now what is R here? What you got? Nth root of z is equal to, you got as cis of, students, 2k pi plus theta by n. No? Now apply here. Before this, r power 1 by n you will get. nth root of z, which is equal to r power 1 by n. Here what is r? For this, r equal to root x square, root 3 whole square, which becomes 3, y square 1. Now r value is 2. Now come back, in the place of r write here 2. 2 power 1 by n. N value is here 4. 2 power 1 by 4. Cis of 2k pi plus theta. Theta means argument of this complex number. So here actually root 3 plus I. Take it as I. Root 3 plus I. Now find whose argument. Argument is equal to, so here real part having positive, imaginary part having positive. Both are positive means which belongs to the first quadrant. So in the first quadrant, argument is tan inverse of mod y by x. You know this. When complex number belongs to the first quadrant, what is its argument? Theta. If it belongs to the second quadrant, pi minus theta. If it belongs to the fourth quadrant, minus theta. If it belongs to the third quadrant, minus pi plus theta. You know, here, what is the argument of a complex number? If it belongs to the first quadrant, theta. If it belongs to the second quadrant, pi minus theta. If it belongs to the third quadrant, minus theta. If it belongs to the fourth quadrant, minus theta. In the third quadrant, minus pi plus theta. You know this, which you have learnt in the complex numbers. Right. Now here y value is how much? 1. So compare this one with x plus iy. Y means coefficient of I. Now tan inverse of, now 1 by x value root 3. Now express this in terms of tan. That angle must be in first quadrant. So in the first quadrant, angle belongs to 0 to 90 degrees. At which angle it is going to be given? 1 by root 3. So tan 30 degrees. So because I have to express this one in terms of tan, because before that tan inverse is there. So tan inverse of tan 30 degrees, pi radians by 6. Okay students? Yes. Now come back, in the place of theta, write pi radians by 6 by n. N value is here 4. Now, okay, what you have to write for k? 0, 1, 2, 3. Till n minus 1 you have to write. Suppose if you put k equal to 0, you get one value. So shall I write all of them? See. If I write k equal to 0, I get 2 power 1 by 4. Now cis of, so this comes into the down. So here it is going to be pi radians by 24 you will get. Leave like that only. If I write k equal to 1, it is going to be 2 power 1 by 4 cis of, tell me students, 2 pi plus pi by 6 whole by 4. If you simplify this, so 6 2s are 12. 12 pi plus pi, 13 pi. So 2 power 1 by 4 cis of 6 2s are 12. 12 plus pi, 13. 13 pi by 24 you will get. Now if you write k equal to 2 over here, then it is going to be 2 power 1 by 4 cis of, tell me what we are writing? K equal to 2 here. So 4 pi. 4 pi plus pi by 6 whole by 4. Now take cross multiplication so that you will get 2 power 1 by 4 cis of 6 4 is 24. 24 plus 5, 25. 25 pi by 24. Now this is obtained by writing k equal to 0. This is obtained by writing k equal to 1. So this is obtained by writing k equal to 2. Now we are going to write one more root for this by writing k equal to 3. Now k equal to 3, if you write there, 2 power 1 by 4, 6 of 2 3 is 6, 6 pi. 6 pi, when you take cross multiplication, 36. 36 plus pi, 37 pi. So 37 pi by 24. So here 1, 2, 3, 4. Because here fourth root of a complex number, you got 4 roots. That roots are here complex roots only. Okay students, this is the way to find nth root of a complex number. I hope you have understood. So now I am going into the nth root of unity. Okay, now let us see nth root of unity. Nth root of unity. See students, nth root of unity, which means that 1 is a real number. Now let us take this value is z. Now, so in place of 1, shall I write in the place of 1 cos 0 degrees plus I sin 0 degrees whole power 1 by n. Shall I write sin 0 0, cos 0 1. Now 1 plus 0 1 only will be left, whole power 1 by n. Now okay, so this one you can write as, apply that nth root of a complex number formula. There we wrote r power 1 by n. Here whose magnitude is 1, no? Because we are writing the roots for unity, means whose magnitude is 1, r equal to 1. So r no need to write here, r power 1 by n. This formula you read. So nth root of z is equal to, so r power 1 by n, cis of 2k pi plus theta by n. You know where k value 0, 1, 2 till n minus 1. Same formula I am going to apply for this. Here principal argument theta is how much? 0 degrees. Now put in the place of theta 0. Okay, in the place of r, what you have to write? 1. So then it is going to be cis of 2k pi by n. Okay students, simply I kept in the place of theta 0, then it becomes 2k pi by n. So here values for k 0, 1, 2, 3 till n minus 1 you have to write. So this is the formula to find nth root of unity. Nth root of unity will get n roots. The roots will be, if you write k equal to 0 here, what kind of roots can you expect? Tell me. If I write 0 here, k, okay, then it is going to be cis 0. So you get one root. What it is? Cos 0 degrees plus I sin 0 degrees. So sin 0 0, cos 0 1. You get a real root by keeping k equal to 0 here. If you put k equal to 1 here, it is going to be cos, if I write k equal to 1 here, it is going to be cos 2 pi by n plus I sin 2 pi by n. So like if you write k equal to 2, you get one more complex root. If I write k equal to 3, you get one more complex root. And so on, you will get n roots for this unity. So let us see, shall I write one more? If I write k equal to 2 here, 2 2 is a 4, cos 4 pi by n plus I sin 4 pi by n, and so on. You will get n roots like this. Among all of them, only 1 is the real root. Remaining all are called imaginary roots or complex roots. Let us consider those roots as 1 comma omega comma. This is 1. Second one is denoted by omega. Third one is omega square and so on, omega power n minus 1. By writing k equal to 0, you got this. By writing k equal to 1, you got this. By writing k equal to 2, you got this. And so on. So this is obtained by writing k equal to n minus 1. So these are n roots of this unity. Remember. Got it, students? So yeah, they may give you n, any value. Either it may be 4 or 3 or 8, whatever it may be. N is any natural number. Okay, these are the roots of this nth root of unity. Here 1 means 1. How it came, you have got it. So omega means here cos 2 pi by n plus I sin 2 pi by n. Omega square means this one. So this is the argument. 2 pi by n is the argument for this complex number. This is the argument. 4 pi by n is the argument for this complex number. Argument, you know. Okay. Angle made by that rotating ray with x-axis is known as argument. That may be there in first quadrant or second or third or fourth. You know, in the previous one we have discussed. So here, what you people are observing? Difference between the argument. Observe the successive roots. 1 omega, omega square and so on, omega power n minus 1. No? These are successive roots of this unity. Now observe the difference between their argument. Here, what is the difference between this argument? 2 pi by n. 4 pi by n minus 2 pi by n. You will get 2 pi by n is the difference between the successive arguments of these two successive complex numbers. These are the roots. What kind of roots? Successive, which are obtained by writing k equal to 1, k equal to 2. Means you can call it as successive roots of this nth root of unity. The difference between their arguments is 2 pi by n. Remember that point. Okay, students? Right. See, these roots of nth root of unity are there in geometric progression. So what is the common ratio of these two? Omega by term 2 by term 1. Omega by 1, which is equal to omega. Now what is the common ratio of these two? Term 3 by term 2. Omega square by omega. Omega you will get. And so on. What it is, students? You are getting ratio between the successive terms is same, na? Hence, so these are forming a geometric progression. Remember that point. Suppose if you would like to get their sum, you can. So find the sum of roots of nth root of unity, which means that you would have to find 1 plus omega square, omega cube and so on, omega power n minus 1. Now how do you find whose sum? Multiply numerator and denominator with 1 minus omega. Otherwise you do one thing. Omega minus 1 you can multiply. Omega minus 1 or 1 minus omega, your wish. Okay, students, shall I multiply with 1 minus omega? Okay. 1 minus omega. Now, product of these two, you know, can be written as 1 power n minus omega power n by 1 minus omega. Okay, students, z is equal to nth root of 1. Now, z is equal to 1 power 1 by n you can write. Now take power on n on both sides. Now z power n minus 1, which is equal to 0. Omega is one of the root of 1 omega, omega square and so on. Omega power n minus 1, no? Omega is one of the root of this equation. Hence put z is equal to omega. Omega power minus 1 equal to 0. Now omega power n is equal to 1. Omega power n equal to 1. Now in the place of omega power n, if you write 1 here, it is going to be 1 minus 1 by 1 minus omega. 1 minus 1, 0. 0 by 1 minus omega, which is equal to 0. So, sum of all the roots of nth root of unity is always equal to 0. Remember that point. See, let us go to find product of all the roots of cube roots of unity. 1 into omega square and so on, omega power n minus 1. Now base is same, add the powers. You get 1 plus 2 plus 3 and so on till n minus 1. So what you have got in the numerator? Sum of first n minus 1 natural numbers. The sum of first n minus 1 natural numbers is n into n minus 1 plus 1, n into n plus 1 by 2, n into n plus 1 by 2. So both of them cancel. Omega power n into n minus 1 by 2. What is omega? So cos of 2 pi by n plus I sin 2 pi by n whole power n into n minus 1 by 2. Now, okay, apply De Moivre theorem for this. So that what do you get? So cos n into n minus 1 by 2 into 2 pi by n plus I into sin, this will come to here, n into n minus 1 by 2, 2 pi by n. Now, see here n cancel, 2 cancel, here n cancel, 2 cancel. You got cos of pi into n minus 1, here sin of pi into n minus 1. So you know, where n belongs to any natural number, I said to you, if you substitute any natural number here, this part would be 0. Take any natural number for n. If you write here, you get sin. Suppose if I take n equal to 4, 4 minus 1, 3. So sin 3 pi, which becomes 0. This part will be always 0. Now what is left? Cos of n minus 1 into pi. So you know, this result would be minus 1 whole power n minus 1. If it is odd, this will be minus 1. If it is even, this result would be 1. Cos 180. Minus 1 no? Cos 360. 0 no? Like that. If this part, if you put n equal to, suppose 4. 4 minus 1, 3. 3 pi. If it is odd, then this will be minus 1. Here, 4 minus 1, 3. Minus 4 odd number, which becomes minus. Whether it is positive or negative, it will be based on n. If n is an even, then this will be minus 1. If n is odd, then this will be positive. Because if it is odd, n is odd. Odd means take n5. So here, 5 minus 1, 4 minus 4 even number, which becomes positive. If it is n is even, 4, 4 minus 1, 3. Here 4 minus 1, 3. Minus 1 you will get. Okay, what is the product of all the roots of nth root of unity? Minus 1 whole power n minus 1. Yes. Next, if you would like to represent this nth roots of unity on the argand plane, you can. Okay, take a unit circle. Take a unit circle. This is a circle of radius 1. Now, x dash, y dash. This is origin. Now you got n roots na? Let us name that n roots as a1, a2, a3. You can. Here you may get a1. Here you may get a2. Here you may get a3. And so on. a4 and so on. a5 and so on. n minus 1. Okay, students. So n roots you will get na? First one. Okay, how much have you got? 1. So you may get that here. So connect this. Okay, 1 comma 0. Where do you get amma? Not there. Here you have to take that. A1 on the x-axis. Because if you write a line on the x-axis, so that principal argument would be 0. Okay? Hence, the root will be 1. So here, a1 comma 0. So this is a2. You know. Okay? So right here, cos 2 pi by n, comma sin 2 pi by n. Second root of nth root of unity is cos 2 pi by n, sin 2 pi by n. So here you get here. So this argument is 2 pi by n you will get. Now this one, the same manner, connect all of them, you will get different roots of nth root of unity. So for this, how much do you get that principal argument? 4 pi by 2n. But this difference is same. From here to here 2 pi by n only. But from here to here 4 pi by n. But if you want this, you have to take difference of these two. So that you will get 2 pi by n only. So here also, this maintains 2 pi by n. So this also maintains equidistancy on the circumference of the circle and so on. Okay students, this is a way to plot nth root of unity on a unit circle on the argand plane or imaginary plane. You know, this is real axis, this is imaginary axis. Okay, right. Now let us go to find cube roots of unity by this nth root of unity formula. What I am asking you to find cube root of unity. Okay, so in my previous classes I taught to you cube roots of unity like this. So cube root of 1, I used to take cube on both sides there, and z cube minus 1 equal to 0. Now factorize it, z minus 1 into z square plus z plus 1 equal to 0. Now we equate both of them equal to 0. Z is equal to 1 and z is equal to minus b plus or minus root 3 I by 2 you will get. So you have taken those roots as 1 omega square, and also you read whose properties. Like this we did na. So but with the help of this nth root of unity formula you can obtain whose roots. Okay, what is the nth root of complex number? Here magnitude is 1 because unity. So here what do you get? Cis of 2k pi plus theta by n, where k is, tell me students, either 0 or 1 or 2. Now if you write k0 here, okay, so for this unity, theta value principal argument is 0, you know that. So here what do you get? Nth root of 1, so which is equal to cis and so on till n minus 1. But if it is applicable for unity, so this will be transformed into 2k pi radians by n. Now here n is k is 0, 1, 2. Now substitute the three values. If I write 0 here, what do I get? 0. So cos 0 plus I sin 0, which becomes 1. So shall I write? See. Put k0. If I write k0, it is going to be cos 0 plus I sin 0. If I write k equal to 1 here, cos n value 3 no here, we are finding the cube roots of unity, means n is 3. So cos 2 pi by 3 plus I sin 2 pi by 3. Now put k equal to 2. You get cos 4 pi by 3 plus I sin 4 pi by 3. Now let us simplify this. It is going to be 1. Now cos 120 value minus 1 by 2. Sin 120 root 3. So that here you will get minus 1 plus root 3 I by 2. So this is cos 4 pi by 3. So you get in the third quadrant. So you get minus 1 minus root 3 I by 2. See, this is a real root and both are complex roots which are denoted by 1 omega square. Both are conjugate to each other. You know that. Conjugate of this is omega square and conjugate of omega square. Conjugate of omega square is omega. Both are conjugate to each other. And take their product. If you add their sum, this sum would be 0. If you their product, omega cube is equal to 1. You know this. And if you represent these 3 on the unit circle on the argand plane, you get like this. X dash, y dash. Now go to the unit circle. Now represent them on the number line. Where it is, you get here. Let it be A, 1, 0. Now x is positive, x is negative, y is positive. Where do you get that? So you may get somewhere here. So x is positive, y is negative. Minus 1 by 2, root 3 by 2. And what about this? Both are negative. X 1 by 2, y minus root 3 by 2. Here, actually, this is the image of this. What it is? Image of this. Minus 1 by 2, minus root 3 by 2. Now connect this. Let it be A, let it be B, let it be C. You got a triangle. This triangle is an equilateral triangle. What kind of triangle is this? Equilateral triangle. If you want that phase difference, means difference of principal arguments. How much do you get? 4 pi by 3 minus 2 pi by 3, which becomes 2 pi by 3. Means this is 120 degrees. Okay, students. I hope you have understood this. So this is the required concept which is useful to tackle the applications related to the competitive exams. I hope you have understood this nth root of a complex number and nth root of a unity. And sometimes they will ask you nth root of a real number also. Nth root of a real number. See here. Nth root of a real number. Suppose nth root of a positive real number. A is a positive real number. So in this case you can write like this. A power 1 by n, and you can take this a as common. So a power 1 by n into nth root of 1 you can write. Okay, students. Nth root of a real number. So you got nth root of unity as 1 omega square and so on, which is equal to omega power n minus 1 na Now all these roots must be multiplied by a power 1 by n. A power 1 by n, a power 1 by n omega, a power 1 by n omega square, and so on. A power 1 by n omega power n minus 1. So these are the roots of nth root of a real number, not complex number. Suppose if you want nth cube root of a real number a, then what will be the roots of this? A is a positive real number. A must be positive, remember this. Actually, what are the cube roots of unity? 1 omega square, no? Now multiply these three with a power 1 by 3. A power 1 by 3, a power 1 by 3 omega, a power 1 by 3 omega square. These are the roots of cube root of a positive real number. So this point also you would have to remember. Thank you, students. I am requesting you to subscribe and share my channel to others so that my classes reaches to many people. Thank you one and all.